Welcome back, everyone. Today, we're diving into an absolutely fascinating topic that might sound a bit niche at first, but I promise you it's anything but. We're talking about desert beetles, specifically the Namib Desert beetle, and their incredible adaptations for survival in one of the harshest environments on Earth. So today's episode is all about desert beetles, masters of moisture in a parched world.
Wait, you mean to tell me that, we're discussing beetles? That just sounds so, unexpected. How do they manage to survive in a place like the Namib Desert?
Absolutely, it's a surprising twist. Picture this. The Namib Desert stretches along the coast of Namibia and is known for its intense heat and dry conditions. Yet, among the dunes, these remarkable beetles find a way to thrive. They engage in what scientists call fog basking. Isn't that wild? They actually harvest moisture from coastal fogs.
Wow, that's, really something. So they, actually drink fog? That sounds almost mythical. How do they pull that off exactly?
Exactly. Their shells have a fascinating design featuring both hydrophobic water-repelling and hydrophilic water-attracting surfaces. The tiny bumps on their shells are hydrophilic, which means when the fog condenses, droplets form on those bumps and then roll right into their mouths. It's like a perfectly engineered water collection system.
That's incredible. I mean, what if we could, create something for humans? I guess fog is everywhere. Could that really solve water issues in dry places?
Absolutely. Scientists are actually investigating that very idea. By mimicking the Namib beetle's technique, there's potential for engineered fog harvesting systems that could gather water efficiently in dry regions.
That sounds so cool. So they're, not just surviving in the desert, they're actually inspiring us to innovate. Wow!
Precisely. And these beetles have additional adaptations to reduce water loss, like waterproof exoskeletons and nocturnal habits to avoid daytime heat. They are nature's little engineers.
Nocturnal habits? That sounds, super interesting. It's almost like how, we sometimes have to adjust our schedules for productivity. Like pulling an all-nighter. They do that just to save water?
You nailed it. They are incredibly efficient. And not only do they conserve water, but they also play vital roles in their ecosystems as decomposers and a food source for other animals. It's all interconnected, like a web of life.
A web of life? It's like a tiny ecosystem within an ecosystem. But, how exactly are they inspiring the designs for these harvesting systems? What features are they looking at?
Great question. So engineers are considering features like a collection surface made from high-density polyethylene, with hydrophilic regions created through nanoparticle coatings that can guide water. They could even design lightweight frames to adjust angles based on conditions like fog density and wind direction.
That's so smart. But, what about maintenance and cost? I can't even imagine what it could take to implement these systems. Are they, economically feasible?
Yes, that's the beauty of it. They're focusing on using inexpensive materials and keeping the assembly simple, which means these systems would be achievable for small communities or agricultural operations in dry regions.
That's, incredible. So you could have entire communities benefiting from a system inspired by something as small as a beetle? It's like nature's design waiting to inspire us, isn't it?
Exactly. Nature truly has so much to offer. With pilot projects starting followed by scaling based on community feedback, it's an exciting time to fuse biology with technology. There's a world of possibilities.
This is, mind-blowing really. Who would have thought that the survival strategies of little bugs could inform our water crisis solutions? What a wild world we live in.
Absolutely. So keep your eyes peeled for any updates on these fascinating projects. Remember, the next time you see a beetle, think about the incredible lessons they hold for us.
I definitely will. It's just so cool to think that such tiny creatures can have such big impacts.